Hello, everyone. If you've joined us for the Key Cordless Kitchen webinar, you're in the right place. I'd like to welcome you all. I'm Paul Golden. I'm with the Wireless Power Consortium. In a few moments, I'm going to introduce my co-host and panelist for the presentation today, Rick Dumont from Philips. But before I get started with that, I want to just make a few general housekeeping comments as we have people that are still joining here as we speak. First of all, this webinar is going to be recorded. So the recording will be available sometime after the event. I'll send an email out to everyone here so you'll see how to access the recording. So you'll see it both visually and an audio. The presentation today is going to be in English. We will have a Chinese translation that will be available shortly after the event. Again, I'll send an email out to people, anyone who is interested in getting the Chinese translation will be able to access that. I think we'll be about 45 minutes in length. That will leave us plenty of time for questions and answers at the end of the session. If you do have questions as we go along, please just put them in the chat and we'll be able to handle those then. So let's go ahead and get started. Pull up our presentation. Okay, so we're here for the Key Cordless Kitchen Seminar. A brief legal requirement before we get started here. The presentation today is mostly copyrighted material, so this material can't be printed or copied without specific permission. If you need to get a copy made or want to have prints made of this thing, you can contact Rick Dumont, and here's his contact information, and you'll have that when we send out the copy for everyone. Today, we will not be trying to sell you anything. This will be an information seminar. I think you'll find it very informative and very interesting. This is the closest thing that'll be to a sales pitch, which is just my telling you a little bit about who the Wireless Power Consortium is and why we exist. We are an open standards organization. We are the global leader in wireless power transfer standards. We were founded in 2008. The first standard, Qi, was launched in 2010. Initially founded with 9 member companies, we are about 350 member companies today. And our mission is very simple. We want to provide consumers and manufacturers with convenient, safe, and interoperable and efficient wireless power. And we provide standardized testing that ensures that the products are certified, that are meeting the standards, that they're safe, and that they are interoperable. We have several standards. Our initial standard, Qi, and most recently the launch of Qi 2, are the global standards for wireless charging of small electronic devices like smartphones, earpods, wireless chargers, etc. They deliver power up to 15 watts. And in a few months, we will be launching Qi 2 with power going up to 25 watts. So you can be looking forward to that. And our newest standard is Qi. Qi is a wireless power standard designed specifically for the kitchen. It delivers the convenience, safety, and a very sleek, modern design kitchen, delivering power up to 2,200 watts, enough to power virtually any kitchen appliance that would normally plug into a wall. So we're providing power to those appliances without cords, without any kind of batteries. So we can get right into the meat of the presentation today. What I'd like to do now is introduce our speaker, Rick Dumont. Rick is the Director of Business Development for the Wireless Power team at Philips. Rick has been instrumental in developing the Qi standard and has worked tirelessly with members and prospective members and helping them develop products and understand what they need to be able to do to get products into market using the Qi standard. And with that, I'm going to turn this over to Rick. Let's see. Okay,
Thanks,
Rick,
Paul.
you should have presentation.
All right, let me put everything in presentation mode. I hope you can see everything fine.
Yes.
Okay.
Yes.
Thanks for the introduction, Paul. Thanks for the nice picture. I might switch off my picture to get you focused on the presentation. Let me see if I can actually do that, or otherwise I just leave it there. I'll briefly take you through a number of items. The presentation is not intended to be deeply technical, although there will be some technical information to explain to you how Key Cordless Kitchen works. So we'll give a brief introduction on how Key Cordless Kitchen or Key Wireless Power is combined with induction cooking, and you will see that there are quite some similarities between induction power and key power, and I'll give you the details of that. We'll tell you about the specification and the outlook, what's coming next after what's there today. I do give you some technical explanation of how Key works and how we have been promoting it together with other partners at various shows like IFA and CS. I'll give you some information about key components and partners that have been developing already building blocks, which actually means that after this presentation, you could already start reaching out and gather information to actually start building products. We also will show you which development tools are available. We will look into some frequently asked questions and then see how we can help to get you started. That's the layout, and these are the items that I hope I can address today. So what is the Key Cordless Kitchen standard? There's actually a standard that intends to deliver wireless power to kitchen appliances. And you see a couple of examples on the right bottom, a water kettle and a blender. And actually, induction power delivers normally power to a piece of cookware that heats it up. In this case, with Key, we capture the power and we drive an appliance with it. So in this way, your induction cooktop can not only be used for cooking, but it can also be used to electrically, without plugging in a cord, wire your appliances. So it enables many cordless kitchen appliances, and it actually enhances the function of an induction cooktop. So we call it therefore a dual function, where you can do both cooking and power transfer on the same spot. Of course, you cannot do it simultaneously, but I just want to stress that if you build or if you have Key Cordless Kitchen in your cooktop, you do not give up that spot for delivering power. You can choose to do your regular cooking on it, or you place a Key appliance on it, and then automatically it starts delivering power to that appliance. Now, also nice in the middle, that power is delivered with induction through a glass plate. You can also deliver it through any surface, any non-metallic surface. And you see here a Key Cordless Kitchen water kettle actually placed on a 20 millimeter granite, and the power is simply transferred through that granite plate. On the left side, and I'll go a bit deeper into that on the next pages, you even see invisible cooking. If you can transfer the power through granite, you can as well do the cooking through granite. And we see more and more invisible induction cooking offerings on the market. And therefore, you kind of like have a countertop that is multifunctional. You can do cooking on it, but on the same spot, you can also put an appliance to power it. Now, the first release to the Key Cordless Kitchen standard is as part of an induction cooktop. So we call it Induction Cooking 2.0. And I mentioned already it's dual function. You can do the cooking as well as the power transfer. Once it is introduced in the market through induction hobs, which can be built in induction hobs or on the counter induction hobs, we can then expand the functionality to hidden transmitters, which are basically mounted under any surface. And then you can actually boil water or power a blender without plugging in a cord. which is simply placed on your countertop under which the transmitter is mounted. Now then the ultimate step, and that's the nice step that we are working towards at the moment, is that once you have all those capabilities available, you can also build that intelligence into your cookware, where you can then actually enable that power function via the cookware, and you have the option to do smart cooking. So in the end, the kitchen that you will have will be a countertop where there is no induction plate visible anymore, where you have several spots that you can cook on or that you can power appliances on, and the cooking can even be smart. So these are the 3 steps that the key cordless kitchen standard is going through. And last year, the formal release of the specification for phase 1 was completed. And the Wireless Power Consortium is now working very hard on completing phase 2 and phase 3 in the next 2 years. Now, what are the benefits of having no cord? Well, first of all, it's convenient. You do not need to plug in a cord. It's clean. You see a very nice example here of a slick surface where you don't see any spots. There is no big cutout for an induction cooktop. It is fully safe, so you cannot burn your fingers. It's also healthy compared to gas, of course, because you don't have any hazardous fumes. It is very space efficient because you can actually use that countertop for any purpose, whereas normally you wouldn't cut your meat on your induction plate. If it's hidden and fully covered under your countertop material, it is a universal space. Now, of course, it's not only about cleanliness, safe, and convenience. It's also about new features. So it actually allows you also, as I mentioned on the previous slide, to enable smart cookware. The other convenience is that for manufacturers, you are not depending anymore on 110 or 220 volt settings like Europe versus the US, since the power interface is wireless. You only need to, as a manufacturer, design one type of appliance, and you can place it on the key cordless kitchen interface. And of course, the nice thing is you can make modern kitchens, and because of removing the cord, it allows you to do also the design of new appliances. Now, the convenience is, of course, because you do not have to plug in the cord, and it is just a matter of placing the appliance on the countertop, and it will automatically be powered on. In this presentation, especially at the end, there are a lot of video links included. So after you have received a copy of the presentation, you can click on the links and you can check for yourselves a couple of very interesting videos and see the actual operation of the key cordless kitchen. Now, how does it work? I'll go into more detail that, but there is actually communication, wireless communication over NFC between the appliance and the countertop, by which the transmitter under the countertop will regulate the power that it sends to the appliances. So it's very interesting to note that there are no batteries. So it's not a wireless charging standard, it's a wireless power standard. So the power delivered is exactly the power that is requested by the device. Of course, the modern design is nice. Today still, even if you have cooking islands, there is a big, I would say, amount of sockets in there that mess up the nice, slick design of your countertop. Having no cords and still being able to cook without additional user interfaces and to power appliances allows really futuristic and slick designs. Now, just to give you an idea that you're not the first ones looking into this technology, there are some very active companies, some big names that are today designing products and are planning to release those products to the market in the course of this year. Now, we will get deeper into that. The release of a product to the market means, of course, that it needs to be tested and certified, and these are also services that the Wireless Power Consortium provides to make sure that the products designed by each of those companies are actually interoperable. Because key cordless kitchen is not just a proprietary technology, it's a standard. And it's a standard that you can recognize by having the logo, as you see on every slide on the right top corner. When this logo is printed on the device, it means that your appliance that you can buy will directly work without any configuration on a countertop that has that functionality. Similar like if you buy an induction piece of cookware, then you can put it on your induction cooktop and it works. Now, to give you some idea of what the key specifications cover, there are actually two basic versions foreseen for the key cordless kitchen. The one I mentioned built as an additional function into, I would say, a standard countertop, and the other one concealed, hidden under the countertop material. The standard for the dual function induction has been released, and under the concealed, we are working on releasing that standard in the course of this year. And then I did show you already number 3, soon to be completed, the key island case. So the key island case actually enables smart cookware, and it can be used under heat resistant, for example, Decton porcelain surfaces. The smart cookware, you'll see an artist impression here, actually controls the heating power. So it communicates with the power transmitter under the countertop. So actually your countertop will look no more or no less than what you see in the left picture. So you can cook on it. You can use your regular cookware if you like, but then you will need a user interface to switch on and control the heating power. If you have smart cookware, you can actually do that via the interface that is built into your smart cookware, and you can either increase, decrease the power, or you can even have a temperature control and control the cookware with your smartphone and do recipe guided cooking. Just this morning, I was discussing with the technical team, and they even convinced me that if you do not have a key cordless kitchen induction cooktop, even then this type of cookware could be used, because also then it's possible actually to read the temperature on your handle and harvest the power from your induction cooktop. So compatibility between devices and also with previous standards is very important to make sure that you have key cordless kitchen as a real upgrade to your cooking experience. So in summary, what does it mean in terms of specifications? As I mentioned, in 2024, end of last year, the key cooktop specification dual function induction was released, and the interoperability testing was completed. In 2025, this year, the certification and interoperability labs will be in place, and actually that will happen already pretty soon. Within April-May timeframe, there will be 2 formally certified labs in Korea and in Europe that can certify the products. We will also be working on regional power specifications, as the initial standard is defined to operate at 220 volts. We of course also like to cover regions with a more limited power capability, as you have in the US a standard socket of 120 volts 15 amps, or in China sometimes sockets of 220 volts 10 amps. That will give a more reduced power that allows you to do less than the 2200 watts that the key specification has, but the standard will make sure that your appliance will still work, be it maybe at reduced performance, but it should still work, because user convenience, that is the most important thing that the standard wants to achieve. I mentioned already, we expect the first key products to be on the market still this year. And then next year, we will further focus on this island specification, the smart cooking, the development of smart cooking devices, and the concealed power under any surface. So that should give you a glimpse on what the key cordless kitchen specification entails and where we are going. Now I'll give you some details on how it works, and I'll try to keep that fairly simple. So as I mentioned, the appliances need to communicate with the transmitter under the countertop, and it's done via NFC. Very often we get the question like, why not Bluetooth? And the very simple reason is that NFC has two major advantages. First of all, it doesn't require a battery in your appliance. So the NFC, like your bank card, is actually powered by the NFC transmitter. Your bank card does not have a battery. It gets simply powered by the reader. That's a big advantage. We do not want to include hazardous batteries in our appliances. Now, the second thing is that it works only in close proximity. So if you take the appliance away, then the communication is also interrupted and the power is cut off immediately. So it's about safety. Even if your appliance would trip over, there's no remaining power transmission field that can be hazardous. So NFC is used for a very specific reason to make it safe and convenient. If you place the appliance on there, it will start to operate. If you take it away, it will stop to operate. Now, this is the most technical slide you will see today, and it actually shows how the NFC is actually combined with the power. Because imagine there is this spot of about, let's say, 10 inches in diameter that will transmit NFC power, and it will transmit very high power for powering your appliance. Now, the way in which it is resolved is that if you look at the nice power field, which are the big red dots, that at the moment that the transmitted power is very low, there is a very short NFC burst, which we call slotted NFC. And that is the way in which both devices, so the transmitter side, the power delivery side, and the appliance side, can communicate. So this picture tries to explain it in a more schematic form. So at the top, you have actually the standard induction hob, which makes an electromagnetic field. It has a coil and it will send it to the other side where the power will be picked up by the appliance. And the lower part of this picture, which is the green part in the green box, is just the control. So the user interface of the appliance sends information over NFC to the other side, and it will control the power that is being delivered. So it's simply like when I switch on a water kettle, then the information will be sent to the other side that the water kettle wants power, and then this electronics will generate the electromagnetic field and it will power the device. In case of a blender, where the power demand might vary because you have stuff in there that is more or less heavy to rotate, the power demand will be higher or lower depending on the load, and all that power is nicely controlled via this NFC communication interface. Now, how does it look in practice? So I added some nice pictures, and on the left you see actually a picture of when the glass plate is taken off from an induction hob. And then actually what we do is just place an NFC antenna on top of that power coil for the communication. So basically, if you look at what is the technology that Keycolor's Kitchen is based on, it's exactly the same power transmitter as what you have today in an induction cooktop, and you add an NFC communication. So normally you would control your power via the user interface from 0 to 9, as a lot of you people might be used to. In this case, that communication and that power control is taken over by sending the commands to the NFC antenna in the transmitter. Now, how does it look on the receiver side? Now, on the receiver side, I have shown here a couple examples. You see on the left side the juicer, and in the middle you see a blender. And if you turn it upside down, in the bottom, you see a power coil, and around that, you see actually one copper winding, which is the NFC antenna. So you have on the left side this 20-watt device, and on the right side, you have actually an 800-watt device, this blender. And on both sides, you have a power coil and an antenna, the antenna for communication and the power coil for receiving the power. Give you a slightly better look at how such a receiver coil looks like. On the right top, you will see actually the nice power coil, and around that, an integrated antenna. Now, the Wireless Power Consortium wanted to take away the effort of companies needing to design their own power coils and antennas. So we, within the Wireless Power Consortium, have engaged with a company that has actually designed a large variety of those coils, including the NFC antenna, so it can be purchased as a building block to be just integrated in your appliance to make things simple. Now you might ask yourselves, you have a lot of different appliances, some like a water kettle, they require over 2000 watts, an air fryer requiring 1500 watts, and here you have like a blender requiring 800 watts, or even a juicer requiring only 20 watts. Well, the Wireless Power Consortium has defined in the key cordless kitchen specification a number of coils, we call them dots, that actually cover any required application. So anywhere in this nice gray area, if you have an appliance that has a certain bottom diameter, let's say of 14 centimeters, and which requires 800 watts, then basically you can use a coil which is somewhere in the middle. So you can choose, for example, a coil number 2 for that purpose. Here you see a water kettle and what are the electronics that is actually needed. So you see the amount of electronics is very limited. It is the NFC communication module, and here you see the power coil for receiving the power. On the right side, there is a slightly bigger picture of how that NFC communication module looks like. Another piece of technology or technical information is that the key cordless kitchen standard has defined 2 device types, call them static and dynamic. You will know that, for example, a water kettle, it only can switch on and off, which means that once it demands power, the power level is always the same. Other devices need a variable power. So if you have this juicer here, then depending on whether you put an orange juice on top and press on it, it will need more power and it will control the power accordingly. And the same holds, of course, for a blender. The sandwich maker or the toaster is also a device which typically, once switched on, gets one fixed amount of power. So we have a static power profile and a dynamic power profile. Now we regularly show these devices at public shows, and I want to just give you a snapshot of how the key cordless kitchen was demonstrated with appliances from various manufacturers. You have here, for example, Midea, Philips, Severin, Jabil, so quite a few manufacturers that have made appliances, and you can see them also on the right picture. And we were honored to receive the Omdia Innovation Award for Key Cordless Kitchen at IFA 2024. Also at CES, there was a large variety of appliances already presented that integrate the Key Cordless Kitchen standard. So you see an air fryer, you see several water kettles, several types of blenders, toasters. So the number of devices is vastly increasing that integrates this technology. I promised you I would give you some insight in the components for a key cordless kitchen that have already been designed in order to make it easier for companies that want to design key cordless kitchen appliances to actually build them without needing to go to the effort of building the individual components. One very active partner in the Wireless Power Consortium is ST Microelectronics, who have developed the complete NFC communication and the key protocol stack. So you can reach out, and there will be address and contact information later on in the presentation. You can reach out to ST for getting that technology. ST has also developed a prototype of a power transmitter, including all the components and a reference design with the software. If you like to build a built-in or an on-the-counter induction hob that can do key, then this reference design would be a perfect basis to start with. SEF in Taiwan has developed the power coils, and I will show you some details about that later. And they are also developing key appliances. Here you see a couple of those power coils for transmitters. In the next slides, I will show you the power coils for the receivers. Now, in order to do your developments, you need equipment. Similar like you need a voltmeter if you want to meet voltages, or an oscilloscope if you want to see waveforms. If you want to develop a key cordless kitchen appliance, you need a piece of equipment that you can put it on and see if it works. Now, just as an example, here there is a company, Defion, that has developed a key development transmitter that can be used as a reference for companies that want to develop key appliances. Also, the counterpart of this device, which is a development receiver, has been developed for those companies that want to develop the induction hobs or the hidden transmitters. And you can put that development receiver on top of it to behave like any appliance. And make sure that the induction hob that you design that integrates key meets the key cordless kitchen specifications. I promise you to show some of the coils. So this is a very nice overview. It's not complete, but it does show you the coils for several power levels. So on the left side, you see 5 different coils that cover very low power, up to 20 or 50 watts, up to high power, 2200 watts. And of course, the bigger the power capability, the bigger the coil. And as mentioned, these coils should basically enable any currently known application to be operated as a key cordless kitchen device. Of course, on the transmitter side, the standard induction coils are available. And in the middle, you see the NFC antenna, which is placed on top of that induction coil. In one of the previous pictures, it was shown as a green PCB coil. But of course, if you integrate it into an induction hob, the temperature is very high. So the coil that you see here is a temperature robust NFC antenna that can withstand the 300 degrees that the induction cooktop coil could reach. Contact information is there if you're interested to acquire coils either for building an induction cooktop with key or for building a key cordless kitchen appliance. SEF will be happy to provide you with the required coils. SEF, by the way, stands for Smart, Easy, Fast. They are one of the founding companies in Asia for induction technology. So they have also a lot of experience to support you and not just deliver you these coils. I mentioned already the ST Microelectronics NFC solution. Here you see actually a bigger part of that transmitter. And you see also the NFC antenna on top of the power transmit spot. Also, they have developed the communication module for the appliances, and the contact details are available on the left bottom. I told you that there are development tools offered to the market for companies that want to develop appliances or cooktops. So I'll show you a couple of slides on those tools. Again, here you see the, as we call it, the key development transmitter, on top of which you can place an appliance. And actually, the development transmitter on one end would say it's a pretty dumb device because it just behaves like key. But on the other side, it's very intelligent because it behaves exactly like a certified key induction cooktop. And if you place a blender on there that requires 20 watt, it will deliver 20 watt. If you put a water kettle on there that needs 2200 watt, it will deliver those 2200 watts. And you will have failure detection indications on that device also for the development of your appliance. Here you see how it's connected. You see actually the device under test on top of that transmitter. You can hook up a laptop and you can actually see the communication between the appliance and the transmitted device. Now this is a bit more complex picture. I just told you can also put test devices on top of an induction cooktop. Now they are actually designed as a box, and for the various coils, for the various power levels, different boxes are available that you can connect to a load, which means that if you want to simulate a water kettle, there will be a box with a high power coil inside, and the load will simply consume 20 to 100 watt. There are also smaller boxes, a box, for example, that would emulate or simulate a juicer, so it would consume something like 20 watts, and then the box, the load box, would just act as a load of 20 watts. And all of these devices are programmable, so you can even simulate a varying load to make sure that when you design your transmitter, you can verify that it operates correctly. Here you see again an outline of that box in the red dotted box to show you that with each of these points, you see in total of 8 points here, there is a dedicated box that you can place on top of your transmitter. Now, you will have a chance to ask quite a few questions in the last 15 minutes of this webinar, but I want to already be ahead of that and show you some of the frequently asked questions. The question we get a lot is like, is it safe? Because people think that sending 20 to 100 watts of electromagnetic power into the air might be potentially dangerous. Well, that concern we can easily take away because the key cordless kitchen, as mentioned several times, actually has borrowed most of its power transmission technology from induction cooking. So it's exactly the same frequency and exactly the same power level, actually even a bit lower than that because the highest induction powers go over 3000 watts. And this is a 20 to 100 watt power transmitter. And similar like for induction cooking, where the power is shielded by your cookware, for key cordless kitchen, the transmitted power is shielded, absorbed by the appliance placed on top of it. And we explained earlier, if you take away the appliance, the communication stops immediately and the power stops immediately. So there is no open radiated field ever that comes from a key cordless kitchen device. In a similar way, like there will never be an open transmitted radiated field from an induction cooktop. So it's a perfectly safe technology that actually brings nothing new when it comes to radiated power. Of course, it would be great if you can put your phone on the key transmitter, but we have actually made it such that that is not allowed. The reason for that is simple. On one hand, it might be convenient. On the other hand, we would not like to motivate people to put their phones on induction cooktops. Because if there's no key inside, the phone will not be detected and you will fry your phone. And similar like you would not today put your phone to be fried on induction cooktop, you should also not put it on a key cordless kitchen transmitter. But as said, the key cordless kitchen transmitter is more safe than the induction cooktop because it will recognize your phone and it will anyway not start transmitting power. But you cannot charge it on the key spot. It's a different standard. And as Paul explained in the very beginning, the standard for Qi, the phone charging, will be expanding also to levels beyond 20 watts for fast charging of your phone. I already mentioned once the certification of key devices. So the Wireless Power Consortium arranges the authorized test labs and the test equipment to make sure that devices are compliant to the key cordless kitchen specification and have an authorization to carry the key cordless kitchen logo on their devices. So once you have passed certification and interoperability in these labs, you will be licensed to have a key cordless kitchen logo. Like any induction transmitter, it can heat metal objects. Actually, induction transmitters are intended to heat metal objects. But of course, if you put a blender on a hidden key transmitter, you do not want a metal object that is close to it be heated or your bank card to be damaged. For that purpose, the bank card detection and also the detection of metal objects that are not part of the intended power transfer, they are detected, and then the transmitter will shut off to avoid that any damage can be done or anyone can get hurt. Now, since I showed you quite a few components of that you could add to the key cordless kitchen induction cooktop and the appliance, the question is always like, what does it cost? What do you add in terms of cost? Of course, on one hand, you lose the cord, which is an important one. You might also redesign the device because there's no cord needed. But for the induction cooktop, most of the technology is already included in the functionality that you have today. So only an NFC module needs to be added. That does not mean that you can retrofit a existing induction cooktop to perform key cordless kitchen. You will need to buy a new one. So it is not a retrofit application because the induction cooktop as it is built in today simply lacks the connection for such an NFC module. For appliances, you have also a power receiver coil that you need to add. And since small power appliances need only small coil with a little copper, that cost will be significantly lower than the high power appliances. So the cost range of adding those components will be somewhere between $3 to $7. Now, if you are interested after this webinar to get more details on the technical side and want to get started, there is a link here that you can click, which gives you a technical introduction. And of course, in the end, if you like to become a member, you have access to all the specifications and you have access to the tools and the certification labs. Now, you can already buy from STMicroelectronics the full kits, as I showed, and of course the coils from SEF. Now, with regards to interoperability and certification, if you want to already test your developments in an early phase, the Wireless Power Consortium meetings that are held 4 times per year also provide the option for members to come together and test whether their devices are interoperable. If the devices are ready for certification, they can be offered to 2 certification labs, as I mentioned. One is Resilient in Belgium, and one is TTA in Korea. And there will be an expansion of the certification labs once more and more companies start offering their devices. These are the first 2, and more will be coming in the next few years. I talked already about the standard completion, where the cooktop standard is released now, and over the next 2 years, more extensions of the standard will be developed and will be released to the members. So if you really want to get involved, then you should consider to become a member. If you want more information about the membership, this is the link you can click to get there. Now, there are some additional materials that I will not go through in the appendix. Once you will receive this presentation, you can click on videos. You have informational videos here. You have contacts that you can reach out to for more information. And you can see Key Cordless Kitchen actually in operation. As you can see, there's a lot of material that you can look at. And that would conclude my presentation. I will hand over back to Paul. Paul, if you like, I will keep the presentation on the screen, or you might want to share yours.
Okay. So why don't you just keep yours up here for now? We'll keep you as presenter.
Right.
We had one question that came in on the chat that I responded to. A question came in about whether the products could be GS certified or get the GS mark, which is, I understand, a safety standard in Germany. That would be, the GS mark would be a separate standard. It's independent of what we do as a standard with Key, or what we do as a standard for the WPC, beyond the purview of what we are. So we would not pursue that, but that certainly would not preclude any member who is developing products, Key products, for pursuing that on their own behalf for their product line.
Correct. Yeah. So with respect to product safety or design according to country regulations, there are two aspects to it. Manufacturers will already need to seek approval similar as for their current products. That's one. Secondly, the Wireless Power Consortium itself has partnerships with a lot of country standardization bodies to make sure that whatever the specification is that the Wireless Power Consortium comes up with, that it's not conflicting with any of the existing safety or EMC standards in any region of the world. And that holds also for NFC, EMC regulations. So all of that is taken care of by the regulation body of the Wireless Power Consortium.
Okay. So if there are any other questions, I'll give you a few minutes here to load them in the chat. Again, we'll have this presentation has all been recorded, so it'll be sent out to everybody, so you'll have all the links that we'll refer to here in the presentation. You can follow up with those. And certainly, you saw there was a list here of the contact information. If you have questions, anything about WPC or any of the materials that Rick showed, you have plenty of contact information to reach out to anyone there. We'll give you just a few more minutes here. We have time still, so if there are any questions, just drop them in the chat.
I saw a question coming in via back channel, which is like, will the NFC device of an appliance be powered or woken up actually by the transmitter? That is indeed the case. I didn't mention it explicitly, but one or the third reason for the NFC as a communication standard is that it allows actually the power transmitter to go in very low standby power. As you might know, there are strong regulations for the standby power of devices. That means that we do not, especially if there is hidden power, we do not want to have a separate switch to switch on and off the power to meet standby power regulations. So that means initially only the NFC transmitter is active, which operates at a very low standby power. It supplies the appliance with NFC power. It wakes up the appliance, and the NFC transmitter provides sufficient power to light up some LEDs. And once through that power, the communication interface is started, the appliance can then activate through giving a command over NFC to the power transmitter. So that is the whole process, how it works, and which allows, without any user interface, without any on-off switch, to on one hand achieve an extremely low standby power of less than 300 milliwatts per power spot, but at the same time allowing to transmit 2200 watts if needed.
Good. If there are any questions, anyone has any questions around the Wireless Power Consortium, membership in the Wireless Power Consortium, how we can help you, further help you develop products on this, you have my contact information there. If you have questions about fees or benefits for membership, please reach out to me, contact me at any time, and happy to let you know. It's a good time. This is a good time, particularly to get involved. if you're interested in developing a key standard and looking at kitchens of the future, the fact that now we've launched the initial standard and are working very quickly on the second phase of that standard. If you're looking to get involved, this is the right time to get in so you can get products developed and get products into market quickly. Let's see, we have a new question that came up here. Okay. A couple of questions. Could they put that link in the chat? There was a question about, let's see, Bruce had a question about, can you put that link in the chat for everyone? But I'm not sure which link you were asking for. If you could still drop that in. The question here is it right if I understand that the NFC module, a part of, okay, this is what you just got. Sorry. We answered that. So Bruce, if you're still on, let me know which link it was you were asking for, and I can see if I can drop that into the chat.
Yeah, I guess there was another question about acoustic feedback. That's a good question. Yes, there is acoustic feedback to the user to notify the user that indeed the device has been placed on a key power spot. What type of acoustic what type of feedback I would say is up to the designer. If you look at the videos, you will see that we love blue lights for standby, and we love red lights for active. And we also implemented the acoustic feedback. I think these are 2 beeps once the device gets connected. But there is a lot of freedom for the designer of the smart appliances or the smart cookware to implement user feedback. The standard prescribes that there should be feedback, whether optical or acoustical.
Okay. Any other questions from anyone? Okay, so why don't we wrap it up then for today? Thank you all for attending. Hope you found this to be informative and interesting. And if you have any follow-up questions, please get them back to me, would be fine. And I will make sure that they're technically oriented. For Rick, I'll make sure that he gets those. And we appreciate your attendance today, and we hope everyone has a great day. We'll get this posted, so we'll have it out to you as a copy very, very quickly. Thank you very much. Have a good day.
Thank you, Paul. Bye-bye.